In this video, we will learn the fundamentals of Celery for task queue in Python and get started with a more advanced framework to run tasks in the background. Celery is a task queue system designed to efficiently distribute work across processes or machines. In this system, tasks are units of work that are queued for processing by dedicated worker processes that continuously monitor the task queue for new jobs. Communication in Celery occurs through messages, typically facilitated by a broker that acts as an intermediary between clients and workers. When a client initiates a task, it sends a message to the queue, and the broker ensures this message is delivered to an available worker. A Celery setup can include multiple workers and brokers, enabling high availability and horizontal scaling for improved performance and reliability. Celery is on the Python package index, so it can be installed directly with standard Python tools like pip. To avoid impact on the system libraries, it's recommended to install it in a virtual environment. Celery requires a message broker to send and receive messages. The default broker is RabbitMQ, which is the default broker and doesn't require any additional dependencies or initial configuration. We can install RabbitMQ directly on the computer if you are using Linux, or run it on Docker, which is perfect for local development. We will use the default settings of RabbitMQ in our examples and thus don't need to have any other configurations. The broker URL should be specified in this form. The transport part is the broker implementation to use, and the default is AMQP, which uses the librabbitmq library if installed or falls back to PyMQP. Both librabbitmq and PyAMQP are libraries used for interacting with RabbitMQ in Python. Only the scheme part transport : / is required. The rest is optional and defaults to the specific transport's default values. So for RabbitMQ, the default URL is AMQP : //. The first thing you need is a Celery instance, which is called a Celery application. The Celery application is used as the entry point for everything you want to do in Celery, like creating tasks and managing workers. The first argument passed to Celery is the name of the current module. In this example, it's tasks, because the module is named tasks.py. The second argument is the broker keyword argument, which specifies the URL of the message broker to use. In this case, RabbitMQ is being used, which is also the default option. Tasks are the fundamental components of Celery applications. A task is essentially a class that can be created from any callable. It serves a dual purpose, defining what occurs when the task is invoked, sending a message, and specifying the behavior when a worker processes that message. We can easily create a task from any callable by using the app task decorator. In this example, we will create a task to send a notification to a remote server. A Celery worker is a process that executes tasks in a distributed task queue managed by Celery. For testing purposes, we can start a worker in the foreground by executing this command. The -a or --app argument specifies the Celery application instance to use. In the simplest form, we can just specify the package or module containing the Celery application instance, and it will be retrieved by Celery automatically. Now everything is ready, and we can run a task in the background with Celery. To call our task, you can use the delay method of the task, which is a handy shortcut to the apply_async method that gives greater control of the task execution. In this example, these two commands are equivalent, and it shows that using the delay method can be much more concise. The task has now been processed in the background by the worker started earlier, and we can verify this by looking at the worker's console output. When you call a task in Celery, it returns an async result instance. This can be used to monitor the task's state, wait for its completion, retrieve its return value, or access the exception and traceback if the task fails. By default, results are not enabled because there isn't a single result backend that fits all applications. Additionally, for many tasks, retaining the return value is unnecessary, making this default a practical choice. However, if you need to perform remote procedure calls or store task results in a database, you'll need to configure Celery to use a result backend. Update the Celery app in tasks.py module to have a backend argument. In this example, we use the RPC result backend, which uses RabbitMQ and sends states back as transient messages. In the context of RabbitMQ, RPC, Remote procedure call refers to a communication pattern where a client requests a service or operation from a remote system via RabbitMQ and waits for a response. This is a common pattern in distributed systems where the client and server interact indirectly through a message broker like RabbitMQ. Now stop and restart the worker and also re-import the tasks in the client to make sure the updated app is used. Then we can save the result and retrieve the task ID, status, and also the result from it. This is it for this video. Thank you for watching. If you enjoyed the video, please subscribe to my channel for more content.